Hey everyone, welcome to the Light Waves Unit launch video. My name is Audrey and I'm an 8th grade science teacher from Chicago, Illinois, and I am really excited to take you through this unit. In this Light Waves unit, the phenomena students focus on is skin cancer in Australia. So their big question is, why is there a higher rate of skin cancer in Australia than in other parts of the world? Before we get into talking more about the unit, there is some pre-work that you should do to help this all make a lot more sense. Please pause the video and hit resume when you have finished the pre-work. Now we are ready to go. So why does this unit matter? First, this unit allows students to build on the knowledge that they already have of energy from force and motion and magnetic fields. They now learn that light carries energy and that energy can cause changes. Second, they can apply this knowledge to think about climate change. They can think about how we can use solar panels for energy, which is really important in today's world. Last, this is the only unit this year with an incredibly real question. Skin cancer is a big problem, not just in Australia, but across the world. When students actually Google this phenomenon, they'll see real articles addressing this problem. This makes this unit a lot more interesting for kids, and it's really awesome that they're solving such an important problem. So let's get into looking at exactly what kids will be doing each chapter. In Chapter 1, students are working to answer the question, how does light from the sun cause cancer? On the first day, students will take their pre-assessment, which will help you gather data as to what kids already know about light waves. On the next day, students jump right into tackling the problem of high skin cancer rates in Australia. They look at a map that shows how much higher the skin cancer rate is in Australia than anywhere else in the world. Next, students will get into a hands-on activity to start finding evidence that light carries energy. They truly love this activity as they're able to see that light can cause changes, such as moving the solar-powered toy. This proves that light carries energy. On the third day, students learn that when materials absorb light's energy, they change. Specifically, they see that when genetic material absorbs light, it becomes damaged, which causes skin cancer. On the last day of Chapter 1, students begin tackling the claims about Australia's high skin cancer rate. So they'll have 3 claims here. Claim 1 is that Australia gets a lot of sunlight. Claim 2 is that it's because there is something different about the sunlight in Australia. And in Claim 3, it's that more people in Australia have skin that is easily damaged by light from the sun. By looking at maps of sunlight and skin cancer rates, students actually refute the first claim pretty early, that Australia has high skin cancer rates because it gets a lot of sun. Because they'll see that Australia gets the same amount of sunlight as Brazil, but has a much higher skin cancer rate. By the end of Chapter 1, students should be at Progress Build 1, which means they understand that light carries energy that can be absorbed by a material, causing the material to change. They'll prove their knowledge on this first focus task. Now, take some time to complete the chapter focus task. Pause the video and hit resume when you are finished. Great! Here is the exemplar answer to the focus task. Students should show that genetic material absorbs energy from the light, causing it to become damaged. Students receive 4 points for the model and 4 points for the written response. Pause the video if you need more time to look it over. You can also check your answer with the provided rubric online. As students move into Chapter 2, they are picking up from where they left off their thinking in Chapter 1 to answer the question, how can the same amount of sunlight cause different skin cancer rates? On the first day, students do a hands-on investigation using flashlights and laser pointers, another student favorite, to learn that different light sources emit different light. On the next day, students further their knowledge of different light sources by actively reading about all the different types of light that make up sunlight. On the third day, students reread the article from the day before and then take their learning a step deeper as they're introduced to wave properties. Students learn that not only do different types of light exist, but that different types of light have different wavelengths. They're able to explore changing these wave properties in the online sim. To end Chapter 2, students learn about how different types of light have different effects on genetic material, leading them to see that ultraviolet light causes damage to genetic material. Next, through various texts and models, students learn about melanin. They look at evidence that proves that melanin protects against skin cancer by absorbing UV light. To end the chapter, students return to the claims about Australia's skin cancer rates. They see that most people in Australia have low levels of melanin, and also see that Australia gets a lot of UV light. This leads them to combine claims 2 and 3, knowing that Australia has a high rate of skin cancer because Australia gets more UV light than other places, and the people in Australia do not have enough melanin to protect against the UV light. By the end of Chapter 2, students should be at Progress Build 2, meaning they understand that different types of light can change a material in different ways. A material can absorb energy from some types of light, but not from others. They prove their knowledge of this progress build on the chapter focus task, in which they use evidence about melanin, UV light, and Australia to write an argumentative response about Australia's high skin cancer rates. Now, take some time to complete the focus task. Click pause on the video and resume when you are finished. Good work! Here is the exemplar answer. Students should be providing evidence and reasoning from all 3 sources to earn full credit. If you need more time to read it, click pause and resume when you are done. You can check your answer with the rubric that is posted online. In Chapter 3, after learning that Australia gets more UV light than other parts of the world, students dig into why this is true. Why does Australia get more UV light than other parts of the world? Students know that Australia gets a lot of UV light. So in order to understand why, they have to learn about other ways light interacts with materials. In a hands-on investigation, students have to try to make the light from a laser pointer hit multiple different materials, including a green cube, a red cube, a mirror, and a transparency sheet. You can note there my student on one of our spirit days, but nonetheless you can see how much fun they have with this activity. By experimenting with these materials, students learn that light can not only be absorbed, but it can be reflected or transmitted as well. The next day, students further their understanding of reflection and transmission by actively reading an article. This is where they learn that transmission and reflection of light do not cause materials to change. They also learn why we see different colors. Students continue to learn about reflection and transmission through the sim, noticing materials transmit or reflect some light but not others. To close out the chapter, students analyze the various molecules that make up the atmosphere. They learn that sulfuric acid reflects UV light, carbon dioxide transmits UV light, and ozone absorbs UV light. By doing a modeling activity, students learned that since Australia has less ozone molecules absorbing the UV light, there is more UV light reaching the surface in Australia, therefore causing more skin cancer. By the end of this chapter, students should have reached Progress Build 3, meaning they understand that light can be absorbed, reflected, or transmitted by a material. If the light is reflected or transmitted, the energy is not absorbed and the material will not change. Students show their knowledge of Progress Build 3 on the Chapter 3 focus task, which includes modeling and writing. Take some time to complete the focus task. Click pause and then resume the video when you are done. Here's the exemplar. Student models and explanation should highlight that since there's less ozone in Australia, more UV light hits the surface. Students earn 4 points for the model and 4 for the response. Click pause if you need more time to look it over. You can also check with the online rubric. In Chapter 4, students apply their knowledge to a new phenomena. In this case, students are figuring out if crabs can see the plankton they eat near the ocean floor. Students are presented with many different evidence cards, and they have the task of annotating them in order to build a strong argument. They look at the different distances the different colors of visible light can transmit through water, and they look at where crabs live in the ocean. After a day of analyzing evidence and crafting an argument, they engage in the science seminar. On the 3rd day, they take what they learned in the seminar and complete their Chapter 4 focus task, which is a formal written argument answering the Chapter 4 question. On the final day of the unit, students take their unit assessment, which we will go over in just a few moments. The Chapter 4 focus task is where students are able to show all that they learned from the seminar. Take a few minutes to complete the task. Please pause the video and resume when you are done. Here is an exemplar for each claim, since students could have argued for either one of the claims. Pause to read over the 2 exemplars and resume when you are done. You can also check your answer with the online rubric. At this point, students have learned all that they need to know to master the end of unit assessment, so we'll take some time now to look at some of the questions together. This is a typical Progress Build 1 question. Please pause the video to complete the question and resume when you are done. The correct answer to this question is C. Students who answer this question correctly understand that light carries energy, and that when energy is absorbed by a material, the material changes. Therefore, the rug was able to take in energy from the light, which caused the rug's color to fade. The most common wrong answer would be D, which is that students think that light from the sun actually pulls the energy out of the rug. We really want to make sure students are understanding that the rug is taking in the energy from the light. Now, let's look at our Progress Build 2 question. Take a minute to complete the question. Click pause and then resume when you are done. The correct answer is A. Students who answered this question know that not only can a material take in energy from the light, but the materials can only take in energy from some types of light. So only some types of light can cause certain materials to change. That's why the glue can only change under light from the sun rather than the lamp. It can only take in energy from the sun's light. The most common wrong answer, again, has to do with the sun pulling energy out of the glue. We want to make sure students are knowing that that the material is taking in or absorbing the energy, and that is what causes change. This is a Progress Build 3 question. Take a minute to answer it. Pause the video and resume when you are done. The correct answer is D. Students who answer this correctly know that a material does not change if it transmits or reflects light. The material only changes if it absorbs light. What's really tricky here is that neither light presented was absorbed by the material. So sometimes students are resistant to picking neither. Students really need to understand that materials really only change if the light is absorbed. Now let's try a constructed response. The constructed response says Tyrell is learning about a certain kind of metal used to make satellites. He learns that infrared light is absorbed by the metal. X-ray light is transmitted through the metal, and visible light is reflected off the metal. Tyrell wonders if the metal will get warm if he shines the light on it. Can light cause the metal to get warm? Why or why not? Does it matter what type of light shines on the metal? Please pause the video to complete the question and resume when you are finished. This exemplar answer here shows knowledge of all 3 progress builds. Each progress build is highlighted. The answer is yes. Light can cause the metal to get warm because light carries energy that can cause materials to change. That's progress build 1. Yes, the type of light matters because materials can only take in energy from some types of light and not others. That's progress build 2. Only the type of light that is absorbed, the infrared light, can cause the metal to get warm because energy is not absorbed and the material does not change if it reflects or transmits the light. That is progress build 3. Thank you, science teachers. I absolutely love getting to watch students think outside the box, explore real-world phenomena, and becoming excited about science through this unit, and I really, really hope that you do too. Before you go, here are some final steps for KIPP teachers. Have so much fun with this unit.